Number 2 for 8b. Um, this uses a new term called parametric equations. This is where you define points. Like if I wanted to define this circle as a parametric equation, I could say let x and y be 3 plus 6 cosine theta, 2 plus 6 sine theta. And in this case, the parameter would be theta. And the idea is that you could essentially plot out a whole bunch of points, cos theta y equals 2 plus 6 sine theta. And you could just plot out a whole bunch of, if theta's 0, if theta's 1, if theta's 2, all the way up to like 360, or you could even keep going if you wanted. And you get all of these coordinates out of this. And if you plotted them all out, you would end up with all the points going around this circle, right? So the idea is that you define this graph in terms of a new parameter instead of just relating x and y directly. So if you look at the first one really just describes the circle centered at the origin. Whoops, centered at 0, 0 with radius equaling 1, right? Because that's the unit circle, right? Radius 1. Here, let me make this a little bit bigger. Radius is 1, and it's gone t degrees, like that. In the second one, it's really the same thing, except notice it's been scaled out by a magnitude of 4. So really what we're doing here is this is going to be a circle centered at 0, 0 with radius equaling 4. In part C, notice it's 4 cos t and 4 sine t again, except now we've moved it a little bit, right? It's been shifted a little bit to the right and down. So this is really going to be a circle centered at 3, negative 2 with radius equaling 4. The last one's a little bit different. The last one, if you think about just cos t sine t, right? That looks like this. Here's t degrees. Radius is 1. And then what happened was the x's got stretched out by 4 and the y's got stretched out by 7. So if you can kind of picture it, if I stretch out the x's by 4, that circle kind of expands out to here. But if I stretch out the y's by 7, then I get an ellipse that looks like this, where this length is 4 and this length is 7, right? So when it's an ellipse centered at 0, 0 with, let's see, we could call this like the minor axis and the major axis. Actually, I think at this point, it's easier to just graph it. So it's this one. So here's 0, 0. It comes out to 4 and negative 4 and up to 7 and down to negative 7. And let me bring these in a little bit. Negative 4 to 4. And it looks like that. So it's an ellipse. Okay, hope that makes sense.